The stars have always called to us, their distant whispers tugging at our curiosity, our longing, our fear of the unknown. Nearly 50 years ago, we answered that call with two tiny machines, Voyager 1 and Voyager 2, sent hurtling into the cosmic abyss to uncover secrets of our solar system and beyond. These probes, no larger than a small car, carried our hopes, our ingenuity, and a golden record etched with the sounds of Earth, a heartbeat, a baby's cry, the strums of Chuck Berry's guitar, meant for anyone or anything that might find them. For decades, they've been our eyes in the void, rewriting what we thought we knew about the universe. They showed us volcanoes erupting on a moon we'd never dreamed could be alive, rings of ice dancing around distant giants, and worlds so cold they defy imagination. But now, as Voyager 2 drifts farther than any human-made object has ever gone, something strange has happened. A cryptic signal, faint and garbled, has reached Earth, and it's left the brilliant minds at NASA uneasy. What could it mean? Is it a glitch in an aging machine, or something more? A message from the edge of the unknown. This is the story of Voyager, a tale of human ambition, cosmic wonder, and a mystery that might just change everything. It all began in the 1970s, a time when bell-bottoms and disco ruled the Earth, but a rare cosmic event was about to ignite our imagination. The planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, aligned in a way that happens only once every 176 years, creating a celestial highway for exploration. NASA seized this moment, crafting a bold plan to send two robotic explorers on a journey no one had dared before. The Voyager spacecraft were born from years of sweat, ingenuity, and a race against time. Engineers poured their hearts into building machines that could survive the freezing cold, blistering radiation, and violent solar storms of deep space. Each probe was a marvel of compact design, standing just 1.5 feet tall, with a wide dish-like antenna stretching nearly 12 feet across to whisper data back to Earth across billions of miles. They carried cameras to capture alien worlds, instruments to measure the invisible forces of the cosmos, and those golden records, our voice to the stars. Launched from Cape Canaveral in 1977, Voyager 2 lifted off first, followed by its sibling, Voyager 1, on a faster track. Few who watched those rockets roar into the sky could have imagined that these machines would outlive their creators, still speaking to us half a century later. The Voyagers were more than machines. They were dreamers just like us. Their mission was to explore the outer giants of our solar system, starting with Jupiter, a planet so massive it could swallow Earth 1,000 times over. In 1979, Voyager 1 arrived, its cameras drinking in a world of swirling, colorful clouds and a storm, the Great Red Spot, raging for centuries. But it was Jupiter's moon Io that stole the show. Scientists expected a dead, cratered rock, but what they saw was a world ablaze with volcanoes, spewing sulfur in vibrant yellows and oranges, painting Io like a cosmic canvas. It was the first time we'd seen volcanic activity beyond Earth, a reminder that the universe is alive in ways we could scarcely imagine. Voyager 2 followed, confirming Io's fiery nature and revealing Jupiter's faint, ghostly rings, proof that even the King of Planets held secrets. Then there was Europa, its icy surface crisscrossed with dark streaks, hinting at a hidden ocean beneath. Could life exist there, in the cold depths of a distant moon? The Voyagers didn't answer that question, but they planted the seed, sparking dreams of future missions. With Jupiter's gravity as a slingshot, the probes sped toward Saturn, their next great adventure, carrying our questions and our awe. Saturn awaited, its rings a shimmering promise of beauty. When Voyager 1 arrived in 1980, it unveiled a world of breathtaking complexity. Those rings, which looked like solid bands from Earth, were a delicate dance of icy particles sculpted by tiny moons, Atlas, Prometheus, Pandora, that shepherded them into intricate patterns. Voyager 1's cameras captured storms swirling in Saturn's atmosphere, less chaotic than Jupiter's, but fierce in their own right. Its radio signals, passing through the rings, revealed they were mostly water ice, sparkling like cosmic snow. The real prize, though, was Titan, Saturn's largest moon, cloaked in a thick, hazy atmosphere richer in nitrogen than Earth's. It felt like peering into a mirror of our planet's ancient past, a world where life might have taken a different path. But this close encounter came at a cost. Voyager 1's trajectory sent it soaring out of the solar system's plane, its path now set for the stars, unable to visit Uranus or Neptune. Voyager 2, however, was on a grander tour. In 1981, it swept past Saturn, adding to its siblings' discoveries and setting its sights on the ice giants. As it left, NASA powered down its cameras to save energy, trusting Voyager 2 to carry our hopes to worlds no human eye had ever seen. Voyager 2's journey to Uranus was a leap into the unknown. In 1986, it reached this pale, tilted planet, a world so cold, minus 350 degrees Fahrenheit, that it seemed to defy life itself. Its dim rings and scarred moons told stories of ancient collisions, and its strange, lopsided magnetic field baffled scientists. 10 new moons were found, each a frozen enigma. Then, in 1989, Voyager 2 reached Neptune, the farthest planet it would ever see. Despite its distance from the Sun, Neptune was alive with ferocious winds and a massive storm called the Great Dark Spot. Its moon Triton was the strangest yet, with geysers spitting icy plumes and an orbit suggesting it was a captured wanderer from the Kuiper Belt. Voyager 2 had done the impossible, visiting all 4 gas giants, rewriting our understanding of the solar system. With its cameras now silent, it turned toward interstellar space, joining its sibling in a journey beyond the sun's reach. But the Voyagers carried more than science. They carried us. Those golden records, with their songs and greetings, were a love letter to the cosmos, a fragile hope that someone, somewhere, might know we existed. Now, in 2025, the Voyagers are farther than ever, drifting through the uncharted territory of interstellar space. Voyager 1 crossed the heliopause, the boundary where the sun's influence fades, in 2012, becoming the first human-made object to leave our solar system. Voyager 2 followed in 2018, its instruments still whispering data about cosmic rays and magnetic fields. But something has changed. A recent signal from Voyager 2, faint and distorted, has stirred unease at NASA. It's not just a glitch, it's a puzzle. A message that doesn't quite make sense. Is it the cry of an aging machine, battered by decades of radiation? Or could it be something else, something we're not ready to understand? The engineers are working tirelessly, coaxing life from these ancient probes, but time is running out. Their power fades with each passing year, and soon they'll fall silent, carrying our dreams into the eternal dark. For now, though, they still speak, and we listen, holding our breath for what they might tell us next. The void is silent, but it holds secrets that hum with possibility. Voyager 2, a tiny speck of human ambition, drifts through interstellar space, its golden record gleaming faintly under starlight that's never touched Earth. For nearly half a century, it has carried our story, our music, our laughter, our hopes, into the cosmic deep. But now, in 2025, something unsettling has stirred. A signal, faint and fractured, has reached NASA's antennas, a whisper from 12 billion miles away that feels less like data and more like a riddle. Scientists huddle over their screens, their hearts pounding with equal parts dread and wonder. Is this just the groan of an aging machine, its circuits frayed by decades of cosmic radiation? Or is it something more, a sign that Voyager 2 has brushed against the edge of something we can't yet comprehend? The mystery grips them, and it grips us, Because this isn't just about a spacecraft. It's about what it means to reach beyond our world, to dare the unknown, and to face the possibility that the universe might be reaching back. The journey to this moment began with a dream, born in the 1970s, when humanity stood at the threshold of the stars. The Voyager probes were marvels of their time, built to withstand the harshest corners of our solar system. Their power came from radioisotope thermoelectric generators, small nuclear hearts that turned the heat of decaying plutonium into electricity. In the dark, far from the sun's warmth, solar panels would have been useless. But these RTGs gave the Voyagers life, letting them send whispers of data across unimaginable distances. Each probe was a masterpiece of engineering, with thrusters to nudge their paths, cameras to capture alien vistas, and instruments to measure the invisible, magnetic fields, cosmic rays, the solar wind's fading breath. But what made them truly special was their human touch. The golden records, crafted under the guidance of Carl Sagan. These 12-inch discs, coated in gold, held greetings in 55 languages, the songs of whales, the rhythm of a heartbeat, and music from Bach to Chuck Berry. They were our way of saying, "We are here," to a universe that might be listening. Etched with a pulsar map, they pointed to Earth, a fragile blue dot in the galactic sea. As Voyager 2 ventured beyond Neptune, its mission shifted from planetary exploration to something even grander, the study of the heliosphere, the bubble of solar wind that surrounds our solar system. This region, shaped by the sun's charged particles, is our last outpost before the vastness of interstellar space. Voyager 1 crossed its boundary, the heliopause, in 2012, a historic moment when humanity's creation first touched the space between stars. Voyager 2 followed in 2018, its instruments confirming a shift in plasma density and cosmic ray intensity, like stepping from a sheltered harbor into an open ocean. The data they sent back revealed a heliosphere that wasn't a perfect sphere, but a lopsided dynamic frontier, shaped by its dance with the galaxy beyond. Every signal was a triumph, traveling over 20 hours to reach Earth's deep space network, a trio of massive antennas in California, Spain, and Australia. These dishes, especially the 230-foot giant in Canberra, strained to catch the probe's faint voices, now weaker than a whisper. NASA's engineers have upgraded the network over decades, amplifying signals so faint they're barely distinguishable from cosmic noise, a testament to our refusal to let go of these distant travelers. But the Voyagers are old, their power dwindling as their RTGs fade. Each year, they lose a little more energy, forcing NASA to make heartbreaking choices about which instruments to shut down. Heaters have been turned off, yet the probes endure in the freezing void, their systems tougher than anyone dared hope. In 2022, Voyager 1 sent a scare, a garbled signal from its attitude control system, as if it had forgotten how to point its antenna at Earth. Yet, impossibly, it stayed locked on, sending clear science data despite the nonsense telemetry. Engineers traced the issue to a failed onboard computer, rerouted the data path, and breathed a sigh of relief as the probe's voice cleared. Voyager 2, though, has been the quieter sibling, its systems holding steady despite minor quirks. Until now. This new signal, arriving in 2025, is different. It's not just corrupted data, it's structured in a way that defies easy explanation, like a language half understood. NASA's team is working around the clock, poring over every bit, knowing that each transmission could be one of the last. The probe's power is expected to give out by 2030, maybe 2035, and when it does, they'll fall silent, drifting forever with their golden records. The mystery of Voyager 2's signal pulls us into a deeper question. What are we searching for out there? The golden records were a gesture of hope, a belief that our story matters, even if no one ever hears it. They carry images of humans laughing, working, loving, diagrams of DNA, and a map to our home. But they also carry our vulnerability, our fleeting existence on a small planet in a vast cosmos. As Voyager 2 drifts through interstellar space, it's not just a machine, it's an extension of us, carrying our curiosity into the unknown. The strange signal could be a glitch, a cosmic ray flipping a bit in an ancient circuit, or it could be something else, a pattern that hints at contact, a phenomenon we don't yet understand, or even a reflection of the universe's own strange music. The scientists at NASA aren't ready to say, but their unease is palpable. They know the stakes. Every day, the Voyagers move farther, their signals weaker, their stories closer to fading. Yet we keep listening, because in those faint whispers, we hear the echo of our own longing to know what lies beyond. The universe is vast, a tapestry of light and shadow where our tiny world is but a fleeting note. Yet, for nearly 50 years, Voyager 2 has carried our voice into that immensity, a fragile emissary bearing our songs, our dreams, and a golden record that whispers, "We were here." Now, in 2025, as it drifts through the interstellar void, 12 billion miles from home, it has sent us a signal that chills the heart. This cryptic message, garbled yet strangely deliberate, has NASA's scientists on edge, their minds racing with possibilities. Is it the last gasp of a machine worn thin by cosmic rays? Or does it hint at something stranger, a whisper from the unknown, a brush with forces we can't yet name? The answer eludes us, but the question burns, pulling us into a story that began with bold ambition and now teeters on the edge of mystery. As we listen to Voyager 2's fading voice, we're reminded of our own place in the cosmos, small, curious, and daring to reach for the stars. The Voyagers were never meant to last this long. Built for a 5-year mission, they've defied time, their nuclear hearts beating slower but still strong. The radioisotope thermoelectric generators, glowing with the heat of decaying plutonium, have powered their journey through the solar system and beyond. But that power is fading, and NASA's engineers face a slow, inevitable loss. They've turned off heaters, dimmed instruments, and rationed every watt to keep the probes alive. Each decision is a quiet heartbreak, a step toward the day when the Voyagers will fall silent, perhaps by 2030 or 2035. Until then, every signal is a miracle, caught by the Deep Space Network's giant antennas in California, Spain, and Australia. The Canberra dish, a 230-foot behemoth, is Voyager 2's lifeline, the only one that can reach it in the southern sky. Upgrades in 2020 and 2021 strengthened its voice, but the probe signals grow fainter, a whisper drowned by the universe's hum. Engineers amplify and decode these threads of data, knowing each could be the last, a fragile link to a machine that's become part of us. This latest signal from Voyager 2, though, is different. Unlike the glitch in 2022, when Voyager 1 sent nonsense telemetry, yet stayed on course, this transmission feels purposeful, almost patterned. It's not random noise, but a sequence that defies the logic of a failing circuit. Scientists pore over it, their screens glowing late into the night, chasing a truth that feels just out of reach. Could it be interference from a cosmic source, a pulsar's pulse, or a flare from a distant star? Or is it something the probe itself detected, a phenomenon in the interstellar medium we've never encountered? The possibility, however remote, that it's a response to the golden record, a message from another intelligence, hangs in the air, unspoken but heavy. The records, with their greetings in 55 languages, their music, their pulsar map pointing to Earth, were a long shot, a gesture of hope against impossible odds. Yet here we are, in 2025, wondering if the universe has answered. The scientists don't dare say it aloud, but the question lingers. What if we're not alone? Beyond the mystery, the Voyager's legacy is a testament to human courage. They've shown us Jupiter's fiery moons, Saturn's delicate rings, Uranus's frozen secrets, and Neptune's wild storms. They've taught us that our solar system is a place of wonder, alive with possibility. Voyager 2's journey through the heliosphere revealed a boundary not smooth, but warped, shaped by the galaxy's unseen forces. Now, in interstellar space, it measures cosmic rays and magnetic fields, sending data that reshapes our understanding of the universe's edges. But it's the golden records that carry our heart. They speak of a species that loves, fights, creates, and dreams. A species that reached out, knowing the chances of being heard were slim. In 40,000 years, Voyager 1 will pass near a star called Gliese 445, and Voyager 2 will follow its own path, perhaps brushing another star. Long after Earth has changed, these probes will drift, silent, carrying our story into the eternal night. As we wait for answers about Voyager 2's signal, we're left with a truth both humbling and profound. We are explorers, even when the unknown terrifies us. The signal may be a glitch, a final cry from a machine pushed beyond its limits. Or it may be a hint of something greater, a clue to mysteries we're only beginning to grasp. Either way, the Voyagers have done more than chart planets or measure particles. They've carried our spirit into the cosmos, reminding us that our curiosity, our need to know, is what makes us human. When their signals fade, they won't be gone. They'll be out there, eternal travelers, bearing our message to the stars. Until that final silence, we'll keep listening, holding our breath for the next whisper from the void, wondering what it might tell us about who we are and what lies beyond.